Assalamu alaikum, dear students. We're back with another video lesson. In the previous video lesson, we were talking about magnetic force on a charged particle. We said that if a charge moves into a magnetic field, it will experience a magnetic force. And we also said that this magnetic force, it is maximum if it goes into a magnetic field at a right angle. It is minimum or zero if it goes parallel into a magnetic field. Obviously, there will be no force. And it is going to be half of maximum if the angle between the motion, the velocity, and the direction of the magnetic field is 30 degrees, because sine 30 obviously it is equal to half. And we also learned about the direction of a magnetic force, Gutman, and you will use the right hand rule, of course, to find the direction. Gutman, remember that the forefinger would be the direction of a magnetic field, thumb would be the direction of the motion of the charged particle here, and then if it is a positive charge, direction force is going to be out of a palm. If it is a negative charge, direction force is going to be out of the back of the hand. These are basic, and I need you to know them. And we've also learned a very easy method, Gutman, Labini direction magnetic force, BUV, Gutman, each one of these, it is going to be on a separate axis. Even if they are both, let's say, even if they are one of them is positive or negative V, they cannot be on the same axis. The angle between each one of these Babylon must be what? Must be 90 degree. We can also say that each one of these is perpendicular to the other one here. That is obviously what it is. You can tell the 20, you can have 50% of the answer correct without even using the right hand rule. For the right hand rule, you could just use that to see if it is positive or negative. We've learned about all this, and of course, if you didn't watch this, go back to the previous lesson, and of course, you'll see how easily it can be done. Of course, today also, we're going to practice more using that, but this is where we stopped at this point right here. Basha, one thing that we have was, we were talking about magnetic force. Regarding the direction of or the magnitude of a magnetic force, Ch.5 sine theta, whether it is positive or negative, that is still the magnitude of the magnetic force. For the direction, obviously, we don't write negative in the equation for the direction, no. We'll use the right hand rule like that. And also, sometimes a lot of students might not get it the first time. Why? Because of something that I taught. Says, what will be the magnitude? The magnitude of a force on an electron here. Sometimes, if you're not careful, this electron might confuse you a little once it passes into a magnetic field. Basha. An electron, obviously, it is negative. Because it says magnitude, force QVB sine theta. Magnitude, obviously, it has no direction. The negative electron, negative Q. This negative represents the direction of the magnetic force, which we don't use that here. Basha, the direction we'll use the right hand rule. Magnitude positive, negative the absolute value. Positive negative positive, and that would be the answer. So if that is the case, which one of these will be correct? Of course, in this case is going to be C, which is going to be QVB sine theta. Whenever it says maximum, sine theta beta 1 QVB would be enough at this point right here. Basha. Now that is for this question here. Now there is more, obviously. Magnetic force QVB. If you want to do the directions or the units here, which is also something very important, but of course we're going to talk about this one more time later. Basha? Yeah. Magnetic force magnetic force QVB force that is in Newton, charge in Coulomb, velocity is meter per second, and then magnetic field is in Tesla. That is what Newton is equivalent to, we can say. Action. But magnetic field subject the beta magnetic force divided by Q V magnetic force is measured in Newton here, Q that is in Coulomb, and then velocity is measured in meter per second. O second the kripsita serie the Newton second the ser Coulomb meter Gutman وجلو زارياتي تو اشتش دي كشي وابد توانين او Coulomb يبينا او second يبينا بن Coulomb. Okay, ماشي. data, because we know that current the charge over time when the amount of charge flowing per unit time data يعني اگر دتواني بلينا كولوم او سكند او دكاتا امبير ونيا كاتا امبير دكاتا امبير دكاتا كولوم over second هرسن the piece بوينابي because we have other questions here. Of course we're going to practice, you'll get the same result as this one. لو حالتي قربين بيش بابا دبيتا كولوم over second باشا times meter ونيا ديرا دتواني بلين نيوتن دكاتا كولوم over second قد ما دبيتا امبير وش دبيتا متر اشتاش ديك اشياء. We know that also frequency دكاتا تبابا frequency هم زارة دكاتا 1 over period, or you can say bubbling, or 1 over period here. Data hertz kata hertz the kata 1 over second. When if I want to rewrite this one separately here, I can have another equation. But these are not the main ones. I want you to focus on the main units here. We're going to go about the main unit. If I go back to this one here, Newton, Coulomb, meter, 1 over second. At this point here, 1 over second can become hertz as well. Probably Newton, Coulomb, meter times hertz as well. But knowing the main units would be more than fair enough at this point. Kata, remember about Pishtir the Mango Tesla, the Kata said the Kata Weber such a Weber Lesser Mater Duzania, Yuntachidike sta Tesla. Of course, now we can say Tesla is equal to what? It is equal to Newton. We can say Newton second, Coulomb meter, Yanish Newton over Coulomb times meter per second. Oh, and I got Libby, because these are very, very important. Basha, minus a unity magnetic field here is Tesla, but also Tesla is equivalent to these units as well. And of course, there will be more, which we're going to be solving, inshallah, soon. These are some of them, right? You can see, for example, where they come from, and there will be more and more. Starting to practice at this point, I believe would be great. Just know the main unit اگر نرزدانش تشيوانيا زور باش بسارش دي كمان هي دلت بابا. Two charged particles are projected into a region where there is a magnetic field perpendicular to their velocities. باشا magnetic field كمان هي it is perpendicular to the velocity of these two charged particles here. أقاليري بابا if the particles are deflected into opposite directions here باشا what can you say about them باشا? Because consider this, we have two charges moving into, here's the diagram, but I'll show another diagram here, Baba. Basha. We have two charges here projected into a magnetic field, Basha. We have two charges here. We don't know what are these or the type of these charges, but once they go into a magnetic field, one of them shifts, let's say, to the right, then the other one shifts to the left one, yeah. Agar Basha. If these two charges move or shift, deflect in opposite direction, what can we say about their charges here? Isn't that because they're shifting in opposite direction? Out of the palm, the back of the hand, because if that is the case, one of them goes one direction, the other one goes opposite direction. These are in opposite direction. We can say these two charges must be opposite because they deflect in opposite direction. Like what would happen if they were both, like the same charge? Of course, they would move in the same direction or deflect in the same direction. Because they deflect in opposite direction, they be charge opposite بالنيرة. Basha. What does it say? It says, Gutman, suppose an electron is chasing a proton up this page when suddenly a magnetic field is pointing into the page is applied. What would happen to the particles? Direction deflects in opposite direction here. You have to specify exactly like what will happen to the proton or direction of the proton and what will happen to the electron as well. Table like BV magnetic force when you do charge money proton electron direction it says chasing the proton up this page kata direction motion proton electron proton when there is an electron chasing a proton up this page kata direction motion it is y positive when direction motion y positive up this page دوباره بس من کرده گفتم بابا y positive y negative x positive x negative كده up this page when you گفتم that will be y positive. What about the magnetic field? It says magnetic field is pointing into the page. Magnetic field pointing into the page and بابا You can see that into the pitch that is Z negative, and this will be the direction of a motion, which is up the pitch. Got a magnetic field into the pitch that is Z negative here. Got a magnetic direction, magnetic force. It's the Baba. Let's say proton, okay, Basha. Man, if it is a proton, it's going to be out of the palm. What about the electron here? If it is electron, that is going to be the back of the hand. When you got to use the right hand rule, Baba. Good man. Direction magnetic field okay into the page. You can see that direction motion okay. It is up this page. Got the which direction is my palm facing? When it is facing to what? To x negative. When you got the x negative, would that be right or left? That is going to be left, right? So this is going to be x negative. Basha for a proton. What about for the electron? Obviously, the electron is going to be opposite because that is the back of the hand. When you which is going to into that direction here. Got that. This one is going to be x positive here. We can say the proton is going to deflect to the left, Basha, to the left. What about the electron? Proton to the left, Basha. What about the electron? The electron is going to deflect, Basha, to the right. To the right. I got no Baba. We also said that by using the right hand rule, of course, you can easily determine which direction they are moving here. But of course you need to know them here since the direction is given, so it is also important to know that. This is not included, by the way, Basha, but of course we need to understand this a little bit to answer the question following this. These are the old generation TV. They had, for example, they were using, let's say, cathode, Basha. There was a filament that was heated up. That filament was giving out electrons. These electrons were projected, of course, onto the screen. The screen was illuminating, and of course it was, let's say, producing or showing you an image on the screen, Basha. But what it was using exactly, it was, you can see that, for example, here we have different stuff. One of the things that we were using, or it was using, let's say, it was using a, let's say, coil or a magnetic force to project these electrons onto the screen right here. Basha, this is how it was working in general, we can say, Basha. Why does the picture on a television screen becomes distorted when a magnet is brought near the screen? Distorted ليه ما بس يعني image كده شيء بابا or deformed, Basha. لبرت magnetic نزيك شاشة كيف كأنه the image will be deformed on the screen. Oh, بابا image كلا screen كيا will be deformed. Take this yandak, Basha. The reason why, because there are electrons moving or striking the screen of the TV, right? So to magnetic baba. We can see that this now, of course, if obviously it has a magnetic field so once these electrons are moving inside the magnetic field of the external magnet, there will be a force or magnetic force on these electrons. Now they're not going to strike the place they're supposed to strike. In this case, of course, the image will be distorted. This magnet, there are electrons that are going to, for example, strike this one here. And you brought a magnet, for example, close to this one here. So there is a magnetic field for this magnet. Now, is that electron, these are inside the magnetic field of this external magnetic field. Of course, there will be a force on them. This force makes them or change their direction, and then now they're not striking the point, or let's say the place that they're supposed to hit, the image or will be deformed. Now, question 13 here says what? A proton moving horizontally enters a region where there is a uniform magnetic field, Basha, and that is, of course, perpendicular to the proton's velocity as shown below. Describe the proton's subsequent motion, Basha. Describe motion and pathy proton كيف Basha. How would an electron behave under the same circumstances? Basha, the electron and how would it behave like in this situation here? Basha, it is very important to notice that, but we usually use the table to make it easier. When you table V man here magnetic force direction magnetic field, as you can see, it is into the page that is Z negative, direction motion for positive charge. Well, it is positive, let's say x positive. What axis is left at this point here? Z man here, x man here, magnetic force y. So now it is either y positive or y negative. Now you can use the right hand rule to determine which one is which. يلا بابا, you can use this one here. But my magnetic field that is into the picture, as you can see, direction motion lexi positive akata. Just kind of like turn your hand a little like this. If that is the case, see which side is my palm facing? It is facing Y positive, right? Kata direction magnetic force protoni baba, it is going to be Y positive here. This is how it is going. But look, right? After it is going, for example, to Y positive, this is what happens here. So there will be a magnetic force in that direction here. Basha, once it is moving on Y positive, what would be the direction of the force on the charge now here, Baba? Situation is that proton, but at this point here, because it is moving inside a magnetic field, this direction motion rule Baba, direction motion after, of course, there was a magnetic force awakened, like so that the electron is moving, for example, towards Y direction. Let's say it makes it bend one, yeah. This is what it was, our direction motion cable. Now, because of a magnetic force, the direction is changed. Of course, it's not going to be at a right angle. It is going to bend or move like like this. But just for simplicity here, we're going to do that so that you have an idea. Direction magnetic direction motion it is bow Y. Magnetic force magnetic force direction it was towards Y positive. Direction motion gora. Basha. Bzamtili deto hamdi sandu bara magnetic field occurs into the page direction motion it is Y positive. Basha. Adi direction force it is going to be on X axis. Is it X positive or negative? Let's find out. The magnetic field is into the picture, as you can see here. Basha direction motion this time it is Y positive. Kata it is proton one, yeah. Kata there will be a magnetic force out of the palm. You can see that out of the palm, which is basically coming towards X negative one, yeah. Kata this time is going to be X negative. Madam X negative, this is how it is going to move one, yeah. Because there will be a magnetic force here, Basha, which makes it move in this direction here. Kata if we draw the path again here, this is how it's not going to be sharp edges here, so this is how it is going to move. Yeah. So as you can see here, it is going into a magnetic field, makes half a circle, or you can say semicircle here, and then after that, for example, because it exits now magnetic field, so at this point it is going to move out of the magnetic field. But if it is out of the magnetic field, there's no force anymore. So in this case, it moves in a straight line. Magnetic force it is moving in a straight line here. It enters the magnetic field, it makes half a circle, and then after that exits. You can see that the path that is exiting and the path that is going into magnetic field, these two will always be parallel to one another. What if it is an electron? It's going to be exactly opposite. So enters a magnetic field, makes half a circle, and then it exits the magnetic field. Again, magnetic field would have made a full circle here, but later the magnetic field so it exits the magnetic field. It is getting out of the magnetic field, and then after that it moves straight. Like question 16 says, at a given instant, a proton moves in a positive X direction in a region where there is a magnetic field in the negative Z direction. What is the direction of a magnetic force? Does the proton continue moving or continue to move along the X positive or X axis? Explain your answer here. Okay, good man. V magnetic force direction, magnetic field. Okay, it tells you that the proton moves in the positive X direction. So here's the direction of motion here, and then in a region where there's a magnetic field, the negative Z, and into the page kata magnetic force. Like what will be the direction of a magnetic force? Just do exactly what we done, Baba. Magnetic field into the page direction motion. Okay, it is Z positive, so just flip your hand. Hopefully you can see that. When you get Y positive, negative, X positive, negative, direction magnetic field into the pager, direction motion X positive. In this case, of course, there will be a magnetic force up the page, right? Up the page, Y positive here. So there will be a magnetic force in Y positive direction here. But the question says, after that says, does the proton continue to move along the X-axis? Obviously not, because if there is a magnetic force on it here, so it is going to change its direction, because now there will be a magnetic force on that here. By the way, we've learned that Pashtari Baba, Basman Gigutman magnetic force, then had direction motion. It does not affect the magnitude of the motion. Basha. It cannot change the magnitude of the velocity, it can only affect the direction of the motion. Now we can answer this question here. The direction of a magnetic force will be along positive y direction or y-axis. Will it continue moving? Let's say on the x-axis? The answer is no. All right, the proton will move in a circular path. All right, let's say in the x and y plane here. X and y plane here. But let me tell you one thing regarding the plane where this charge is moving into here. This is something very important. Basha, I haven't mentioned before. I need you to take a look or focus at this point here. If a charge is moving into if it is a charge moving into a magnetic field, magnetic field it is into the page. Basha. So here is magnetic field, and then this is the direction of a motion here. And then obviously once it goes into magnetic field, there will be a force on it. So make a table, Baba. Man, here's a table. Man, B, V, magnetic force. Basha is the direction B, Z negative, direction force case. Afu, velocity X positive. This is Z negative, Basha. And then the direction of a force, Baba, you can see that, for example. If not, you could look at it on a table as well. And into the page, direction motion there will be a magnetic force. You can see that will be up the page in here. So this is how it is going to move here. Later, if we do this one, for example, the direction of a magnetic field into direction motion direction force it is going to be towards x-axis, x negative, obviously. So this is how it is going to continue here. And then after that here, of course, there's going to be a magnetic force downward here. So this is how it is going to move. And then eventually this is how it is going to move. Direction motion later direction motion it is on x-axis positive here. Later direction motion it is on y positive. Later direction motion it is on x negative here. Later direction motion it is on, we can say, y negative. Later, like how do I know exactly what plane the object or the charge is moving, Baba? By the way, the charge can never move. The charge can never move in the same direction as a magnetic field. Basha, the plane, Basha, you can always say that this too, it is going to be the plane of the charge movement. The plane of what? The plane of charge movement. The plane of charge movement. Later, obviously, if we have a charge moving into magnetic field or right angle, Basha, the charge end up moving inside the field. بس كلنا charge يعني بابلنك charge كلنا magnetic field move the beaten لسه axis شيء charge كده صورته باشا كمان هم جاري نكريد direction magnetic direction motion direction field parallel بنيان same direction بتسكر same direction there will be no force باشا هم جاري أصلاً ترين شتوي بابا direction magnetic field ليه بدره يعني direction magnetic field هرش تكبو take that out of the thing, of course, then the other two directions are obviously going to be the direction or the plane where the magnetic, the direction where the magnetic, or the direction where the charge is moving, or the plane where the charge is moving. If a charge moves into a magnetic field, let's plane it charge and in what plane the charge will move. In a charge move, that means what axis is the charge moving. Let's say axis that charge move direction direction magnetic field direction that is not the plane. That would be the direction of and that would be the plane where the charge is moving. But man is u x katalera y shmane man y positive man habulaw khali once it is moving into a magnetic field kata agar direction magnetic field dake lela baba او دويدي كده بيت a plane of charge movement here باشا يعني او plane ka charge كلنا the صورتها it is going to be the other two components. So the direction كهرش تشديك ابو بابا that would be totally fine. The electronic بابا let me give you another example. What if the direction of a magnetic field, of course, was something like this? Direction magnetic field, which is obviously positive z, positive x. What am I saying? Positive x. Basha. I get a charge manabu. let's say this charge is babbling kaka charge كمان here negative outside اللي هم positive بيتن. We have a negative charges going into a magnetic field باشا و directionally motion كده تواني بلاي directionally motion كده ليرة there زور باشا. If we use the table here ها بابا تماشى كتمان B V magnetic force كتمان أقرب تيه directionally يعني بابلين plane movement كده بزاني magnetic field كده لابا plane كده بيتا بابلين axis يعني component view B كليرة عفوا view F okay باشا ليرة directionally magnetic field كده بابا it is X positive directionally motion كده it is Y positive كاتا دبي directionally force كده تبيتن it has to be Z when yeah is that Z positive or negative بابا let's find out. But obviously it doesn't matter. It's going to be is that we can say that the direction and the plane of the movement for electron with my magnetic field كلي بدري أو دي كده be the direction and babbling the plane where the electron is moving. باشا is that let me tell you how exactly. Here قلت man magnetic field كبابا it is X positive as you can see directionally motion it is obviously the Y positive when it but for the electron I got Libby Baba it is out of babbling the back of it is the back of the hand when you got the first of all here the electron is moving let's say upward here or you can say out of the page يعني شبابا يعني Z positive باشا بس استاكبوا Z positive what exactly happened there أو directionally motion كي باشا is the directionally motion if you want to continue good man magnetic field هرعين نشتا باشا that is going to be X positive directionally motion because now it is moving Z positive after that for example this is how it is going to it goes out of the page when this is how it is going to move out of the page madam it is moving out of the page obviously it is going to move in a circle like this one so this is or these are the two planes that is moving here and this is how it is going to move in a circle we can see that but it's not going to move in bubbling plane X basha this is how it is going to move now if that is the case let's do the next thing here good man direction motion Z positive the direction force it has to be Y at this point here basha is that going to be Y positive or negative man this is how it is going to first of all it was moving what? It was moving Y positive so it's that Z shman here got that Y Z man here that's the only thing you need to know but if you want to know what circle is that going to be obviously it has to be moving in this case here so it is going to be what moving at this point it has to be moving Y negative let's just find out which one it is at this point here and directionally magnetic field X positive باشا directionally motion Z positive which way is the back of my hand is pointing it is pointing Y negative right so Y negative that means this is how it is going to move بس هو اللي رجرينج بابا تبيس بوينيا تنا هم زارك أجر قوتي charge كله تبلينة شيء ده صورتها magnetic field كله هر بلينة شيء بو أو إلابا do axis دي كده بيت plane motiony charge so whether the charge is positive or negative you can easily tell and that'll be the answer to this question I got Libby. All right going back to this one here now the proton obviously for that the proton will move in a circular babbling X and Y plane let's plane it to move the button madam the magnetic field is in Z axis here basha or in this direction here what is left now X Y so we can say that the magnetic field it is moving in the X and Y plane regarding the direction baba that is question 17 and 27 first I'll do 27 and then after that I'll get back to 17 basha now I also would love you would love to see you pausing the video baba just to see for example can you do them or not and then after that you can check your answers with mine of course just to see how well they did زور باش ليرة قلت من دوباره table كي اللي خدرسكو right and then after that things would be very easy at this point here ليرة قلت من B man here V man here لقى magnetic force كي بسارة كتلت سبابة تلا find the direction of a force بس don't jump onto the for example conclusion using the diagram only baba because of course there's something you need to do if it is positive it is going to be out of the palm if it is negative that is going to be out of the back of the hand read the question says the find the direction of a magnetic force on a proton moving through let's say each magnetic field in the figures below كاتا أو ليرة تبكر ذيني ما بتسي the direction of force on a proton ليرة تاخد positive charge بنوسا. What did we do here? ناخد قطمان positive charge ليرة بنوسا. That is obviously قطمان out of the palm of the hand لبري proton. زور باشا. Now at this point here قطمان ليرة بابا direction magnetic field here is Z negative. باشا. Direction motion you can see that obviously up is Y positive here. I mean on this screen here, below that is Y negative, X positive, X negative. ليرة قطمان into that is Z negative. There is going to be Y positive. كاتا فرصة كتبي لسه تسبي Z مان هي Z مان هي Y مان هي كاتا magnetic فرصة كتبي لسه X بيت نعفو. X positive and negative. Now you can use the right hand rule one yeah. يلا بقى أو بينا this is the paper and plane of the page that you have. Magnetic field into the page direction motion Y positive. Madam it is positive charge is going to be out of your palm when that's the Rui palm baba now that's the Rui here. It is pointing X negative when Madam this would be the answer for the first one here. That easy yani. Kata direction magnetic force it is X negative. X negative you can also say to the left. And of course you can also say west as well. Depending on whatever the option, whatever is written in the option, you could choose one of these. X negative, left or west. Of course there's going to be one of these given in the question. You might say, or some of you might say, Mr. what about like two of these are given? No, none of cannot be, two of these cannot be given kak. I get basi madam, like for example, or if there's something else, I get z x choose the coordinate that is given. But I get coordinate that can mention rasta, and of course they will not give you like 2 or 3 correct answers here. Unless, for example, say all of them the cribble x negative, west or left. Let's do the second one here. That was A that we did. Let's try B. Do better. B, V magnetic force one. It's about it. Okay. Let's not try it. So we do this. It's that direction magnetic field it is X positive. What direction magnetic field? What about the direction of motion? That is Y positive. It's like a Z axis one. The magnetic force on a charge, of course, obviously is going to be Z positive or negative. Let's use the right hand rule. Direction magnetic field X positive, X positive. Direction motion Y positive, Y positive. Kata, which way is my palm facing? It is facing into the page. X Z negative. I feel well done. Very good. That is B. What about C here? C the kat later. Direction magnetic field it is Y negative, as you can see here. Y negative. Direction motion it is X negative. Or X negative. Kata, what is left? Z axis is left here. Let's try this one again. Now, what about this one here? If you want to do this one correctly, this is the bottom of the page. You can see that is Y negative. But if I do this, that is opposite to this one. So in this case, of course, this is what I'm going to do here. Now, this is magnetic field into or towards the bottom of the page. I'll just flip my hand. If I want to use the same perspective that you're using, Baba, just put the, for example, book to your left here. You could do this one. The magnetic field is below the page, towards the bottom of the page here, which as you can see here, the bottom of the page, magnetic bubbling direction motion, it is Z, that is X negative, the direction of the magnetic force on a proton is going to be out of your palm, which is facing upward here, which in this case is going to be Z positive, and that'll be it. Negative and negative B. You can see these are opposite here. The negative B depending on the direction of the motion that is given here. Always use the right hand rule just to be on a safe side. What is left now? D is left one, let's try this one too. Magnetic field it is out of the page. You can see that point means out of the page. Out of the page Z positive. The direction motion you can see that it is what? The direction of the motion it is X negative. زور باش كات direction force دي بلسه بيت المابا دي بلسه Y axis بها مشا وما بس نانويا كبابا you already know half of the answer 50% chance هي الذكرية مثلا اگر هر right hand rule شد نزاني ككيانات positive and negative يعني لو دوي درسي يسيدي كيتي ذاني أوجا try to use the right hand rule here بابا. Let me get the same perspective that you have. Gutman, I got the magnetic field that is out of the page baba. This is what you're supposed to do. Gutman 20 elbow the sir paper dani and you could do this one too here. That's the same thing here. Out of the page. Directionally magnetic directionally motion it is XC negative one yeah. Zorbash kata which way my palm is facing? My palm is facing out of the page one yeah. Kata is going to be Y positive and that is the direction here. That's how easy you could do or solve these questions baba. The heat space but it should not by using the right trick and the right method, of course, you could do this very, very easily. After you do the questions, of course, you could check just to see, for example, how it is. Like I said earlier here, later the kriyama blend Y positive, the kriya blend towards the top of a page and up the page, yeah, north on Hamiya say. Later, which is similar to what we have. بس ليه بساركة عندك جواز بساركة what does it say? It says for each situation below use what? Use the movement of a positively charged particle on the direction of a magnetic force acting on it to find the direction of the magnetic field here. ماشي؟ قاعد لي بابا كانت direction اشتكاني دايني. Let's say for each situation below use the movement of a positively charged particle. Hamdi sandu bara baba. Chow charge this positive yani out of your palm and then find the direction of what? Find the direction of a magnetic field. Here it's money later. Let's make this one a bit smaller. Baba later height man. What we have ماشي ضليت بينه ضل directionally magnetic field لكي بينه هر عينا شو table لكي بكو ب V magnetic force ماشي بس ليه ركشت ماني بشتري دمان قهم زاري like every single time baba if you have the direction of a magnetic field always align your hand with the direction of a magnetic field first بس you can always point in the direction of the velocity here هموزا بعد direction of like start with the direction of did I say velocity? Start with the direction of a magnetic force always, and then second would be the direction of a velocity where you can find the direction of a magnetic field. That would be easier. Otherwise, you can align your hand with, like for example, with whatever that you want. It's totally fine. If you align your hand with the direction of a magnetic force, it makes it easier. Yes, like you can see that the direction of a magnetic force, it is what? It is Y positive. When you Y positive direction velocity rule baba X positive. Akata the direction magnetic field the lesser chebi, the lesser Z. Yeah, is that Z positive or negative? Now you have to find out. First direction magnetic force baba. And don't forget this is for a positive charge, which is that means your palm when you keyword make sure that your palm is facing what? Your palm is facing Y positive. So how can I do this? This Y positive, right? If I do this, my palm is facing Y positive. What about the direction of velocity here? So that the velocity, hopefully you can see that it is not in the right direction. What can I do here to do this? My palm is facing Y positive for the direction of velocity to be X positive. But can I do this here? So my palm is still Y positive. The direction of a velocity X positive. Got that direction magnetic field. Look, it is what? It is into the page or Z negative here. And that is the first one here. All right, that is A. What about the second one here? So this is how easy you could do this one. Part B. You can see that the direction of a magnetic force, it is what? It is Y positive dubara. Magnetic force, start with that first. And then the direction of a velocity, it is out of the page, yani Z positive baba. And then kata direction magnetic field X. It is either X positive or X negative, and that is everything you need to know. Yalla baba, Gutman, it comes out direction. Gutman, the direction of your palm must be facing Y positive. That is Y positive, you can see. But the direction of a motion, it is out of the page. How can I do this? This is X negative, right? So how can I make it Z positive here out of the page? That is the correct one. My palm is still facing Y positive. Bubble and velocity, it is out of the pitch, Z positive. Kata magnetic field direction X positive and negative. X positive. That is the direction of the magnetic, direction of a magnetic field. Yes. What about the third one here? C. Masha, let's do C. On the direction of a magnetic force, it is X negative. Direction velocity, you can see that it says in, you can see across, in that means Z negative. Masha, direction magnetic field direction magnetic field Y bit. Is that Y positive or negative? You can use the right hand rule to find out. يلا بابا قلت ما ليه direction force X negative. Cool direction force X negative. Make sure that your palm is facing X negative, and that is X negative. Later direction motion it is into the page, baba. This is out of the page. How can I make that into the page? Now I'll have to do something like this. Just flip your hand like 180 degrees, in this case, or vertically. You can see that here. Basha, direction of Balin, and of course you could do that too here if you want to. It's a little bit hard actually. I'll just go back to what I was doing here. That is your perspective, Baba. Magnetic field is into, it is X negative, Gutman. In order to do this, Gutman, the direction of the velocity is into the pitch. That is the only correct way you can see that. That is magnetic force X negative, velocity into the pitch, got that direction, magnetic field it is. You can see that my 4 fingers pointing below the page, that is Y negative, and that is going to be the direction of a magnetic field for this one here. Also, you can say Y negative or to the bottom of a page. You can say south as well if you want to. So whichever one of these is given, you can choose them based on the option that is given. This is how easy these questions can be, Baba. Of course, with enough practice, you could do these questions very, very easily. Let's solve a few of these questions here. Now let's say, according to the right-hand rule, what is the direction of a force on an electron? If it is an electron here, if it is an electron, the back of hand, force on electron, so it is going to be the back of the hand. Out of the palm, no. Out of the back of the hand, yes. The direction of the thumb, that is not. In the direction of the finger, that is also no, which is, so the correct answer is B here. I would like to come back for this question later. We'll talk about circular bubbling or magnetic centripetal force for magnetic force, and then after that we'll get back to question number 2. Baba, you could solve this one for yourself as well. It says in the figure to the right, what is the direction of a magnetic force on a proton moving inside a magnetic field? Basha? V magnetic force here. Later, what we have, let me start with option D first, maybe. But especially direction magnetic field is into the page Z negative or Y positive. Direction magnetic force proton this is out of your palm. But this one says down the page magnetic force down the page Y negative. The كري Y man heavy but man خير ناكري كاتا not D up the page Y positive. The كري Y man heavy أوش ناكري كاتا not even this one. To the left بابا to the left to the left to the right man here to the left X negative. Is that true? Okay, Basha. Now, is it true, for example, to the left, Kaka? If you do this one here, for example, magnetic field into, and that is Y positive, so it is going to be what? It is going to be to the left. This is correct, Basha. What about this one says to the right, Kaka? Get to the right bit, and that is going to be X positive. Would that be correct? No, because if it is to the right, Danny, that is the back of the hand. That would be true if it was electron. Kaka, this one is incorrect for this question here. That's how easy it is. All right, now question 4 says, an electron moving north encounters uniform magnetic field. If the magnetic field, Basha, points east, what is the direction of the magnetic force on an electron here? Just do the table, and of course, you could easily get this one correct, Baba. Magnetic field V and magnetic force. This is going to be the back of your hand. Magnetic electron moving north. North Baba, that one in blend Y positive, let's get north here. Magnetic field points east. East, that one in blend X here. Magnetic force beta, Z direction. Is that Z positive or negative? You could do that, this one here. Baba, bring this paper again one more time. طبعا magnetic بمعنى قربي معناها start with magnetic field first, that is x positive, velocity y positive. Madam, it is electron, Baba, the back of your hand, which is going to be out of the page, or you can say upward one, yeah, out of the page here. That means upwards here. Which one of these, of course, represents upward? That is going to be B, and that'll be the correct answer here. The magnetic force effect on electron on the, like, when is it maximum? Maximum the B if it is moving into magnetic field at right angle. Look at the B. And of course, you can also answer this question too here using the table we just talked about. Yeah. On the figure, find the direction of a magnetic force on a proton moving with a velocity v through a magnetic field. As you can see here, this is the direction of B, which is y positive, and then the direction of the motion, it is out of the page. The direction of magnetic force, okay, it is on a proton, which is going to be towards xe negative. Xe negative, it is to the left of the page. That is, what is it going to look like here at this point? The last question for this Wazari questions here, and that is this question. Let's suppose we have 4 charges, Q1, Q2, Q3, and 4, moving in a circular path in a magnetic field. As in the figures, which of them is positive? Which of them is positive charge, or you can say which of them are positive charges here. So now, we're going to use the right hand rule. For example, if it is going to be out of the palm, obviously it is going to be for positive. If it is the back of the hand, it's going to be negative. So at this point here, we have a magnetic field is into the page. I'll just do this one on the diagram. Let's see here. You can see that magnetic field, okay, into the page. Direction of motion, okay, it is y positive. Direction of force, okay, it is out of the palm. If it is out of the palm, no charge must be positive. This is what we have. Madam, the force is out of the palm. This charge must be what? Must be positive. So Q1 is positive. Q1 is positive. What about Q2, Baba? Direction of magnetic field, okay, it is out of the page. So you could do this. Direction of motion, okay, it is, you can see that it is y positive. This is what it is. That's the second one here. But man, if watch this one here, you can see that the force is coming out of the back of the hand. Yeah, madam, it is coming, because this is the direction of the force. Because it is coming out from the back of the hand, this charge must be what? Must be negative. Because I get positive, the bad direction of force, okay, so in this case, this charge must be negative. That is Q2 here. What about Q3, Baba? Man, direction magnetic field, okay, into the page, but hand direction of motion, okay, it is, you can see that this is towards the bottom of a page. Direction magnetic force, okay, it is coming out of the back of the hand, madam. Because it is the back of the hand, it is negative. That would have been positive. What about this one here? Direction, okay, it is out of the page. Direction motion, okay, it is towards the bottom of a page. This is what you need to do. You can see that the direction of a force is out of the palm. If it is out of the palm, this charge must be positive. So this is positive here. So how many charges are positive now? It is charge 1 and charge 4. Which one is charge 1 and 4? And that is option A here. بسارة كان زور عسانا قر بونو عن نخد حلقة. يلا بقى بسارة شديك عندك بسارة حسابي calculation. The first thing, we have a sample problem. بسارة نبيك حلقة. A proton moving east. A proton moving east experiences a force of this much, so there's a force in here. So we have a magnetic force upwards, and due to the Earth's magnetic field at this location, the field has a magnitude of, this is, we can say magnitude, and we have B. This is magnetic force, this is magnetic field. Find the speed of the particle. Speed of the particle, and V, right? We said earlier here that magnetic force Q V B sine theta. And because the question tells you at right angle, but at this point you don't have to mention this one here, because sine 90 it is 1. If it is not parallel, and if the angle is not given, it is always maximum, so you don't have to write the sine theta here. زۆر باشە مەچمان دێ بابا V-ەکەمان دەکاتە V دەکاتە چێ V دەکاتە magnetic force لەسەر QB here. magnetic forceەکەمان چەندە؟ magnetic forceەکە دەکاتە 8.8 times 10 to the power negative 90 Newton divided by the charge, by the way. It is a proton, is one charge, and you need to know this one. The charge of proton and electron are the same, which is 1.6 baba times 10 to the power negative 19, or times magnetic field strength, which is 5.5 times 10 to the power negative 5 Tesla. All you have to do is just do the math, and you can find the velocity that is equal to this much meter per second, and that'll be the answer. The direction should not count because it gave the direction itself, so you don't have to worry about this one here. Practice 5D, the first one here says if an electron this time, in an electron beam experiences a downward force of this much while traveling in a magnetic field of this much west, what is the direction and magnitude of the velocity? What it wants about direction, magnitude of what? Of the velocity here. So at this point, it is a must. You need to find the magnitude and the direction of the velocity this time. So let's do this one here. Magnetic force it's a QVB, right? Good man, I get angle like in the it's not parallel, you don't have to write sine theta. It tells you, like downward, and so you can see that the angle between these is 90. Velocity the magnetic force QB, right? Magnetic force it is 2.0 times 10 to the power negative 14 Newton divided by the charge of an electron, which is still 1.6 times 10 to the power negative 19 times magnetic field it is 8.3 times 10 to the power negative 2. So what is the magnitude of the velocity here? Calculate that is equal to this much meter per second. But this is for the magnitude. What about for the direction, Baba? Make the table very easy. B, V, magnetic force. But we can see that this is the only question, by the way, where we have magnetic field and magnetic force, but not the direction of a velocity here. Direction magnetic field of velocity man force man dito force كمان ديتو ده بسارش دي كمان هبو direction force field velocity كمان هبو magnetic field كمان ديتو بس later we can tell you that this is the only question, or the question that we have, where we have magnetic field, magnetic force plus direction velocity كمان we قاعد له بسارنا ببابا, and that's been of course in Wazari as well. Direction velocity كمان ندريتي later دله an electron experiences a downward force. ما دام دله downward force يعني direction force كيتسي بابا negative z downward. Again, it doesn't say down bubbling towards the bottom of a page and down the page. Downward يعني it is z negative at this point while traveling in a magnetic field west. West يعني تبابا يعني x negative the 20 بلان. كاتا استدبي direction velocity كرولة شيبتن. We have x and we have z kata direction motion to be y. Is it y positive or negative? Now all you have to do is just use the right hand rule and that'll be it. Direction magnetic field start with the direction of a magnetic field first. Kata magnetic field x negative. We could do this. That is x negative. Or magnetic field the magnetic force بس بشوي واش هالكي قال لي بدل electron kata. It has to be the back of your hand So back of your hand there is z negative. Magnetic field x negative. You can see that direction magnetic force it is z negative. So all you have to do is just flip your hand here, right? So I'll just do this one here. Direction magnetic field is z. Direction magnetic field is x negative. Direction force it is towards into the page bubbling. Direction motion it has to be what? It has to be y positive So why are we using the back of the hands? Electron that is going to be y what? Y positive. But because these are given, let's say downward west and all that. Y positive the beta north. يعني جدت وانا play up the page. بس ما دام west عندنا بابا, we can say this is north, and this is how easily you could do this question without any problem here. And that is this question here. Let's say uniform 1.5 magnetic field points north of an electron. Again, electron يعني negative. Negative especially when it comes to the direction here. moves vertically downward towards the ground with the speed of this much through this, what force, magnitude and direction will act on it. قلت ما بس فرصة كمان كده فرصة كده كانت negative. No, we don't do this crack. It's easier to use the other. ما ليه بابا magnetic force كده كانت QVB وانيا ليه قلت ما Q كمان هي it is an electron 1.6 times 10 to the power negative 19 velocity كشمان هي which is 2.5 times 10 to the power negative 7 magnetic field كشمان هي it is 1.5 Tesla. You can find the magnetic force. What about the direction بابا? Make the table again وانيا on BV magnetic force I got be negative يعني the back of the hand here. قلت ما field it says magnetic field points north. Got that this is Y positive. And then direction says moves vertically downward towards the ground with the speed of this much. Direction motion but is Z negative because it says vertically downward. I got got that direction magnetic force. Okay, the B X. Is that X positive or negative? You can just find it out. So I got electron magnetic field is Y positive. Direction motion it is into the page. Kata direction motion قلت man the back of the hand because there is electron بابا kata it is towards X negative. X negative يعني that one play it is directed towards west. ماشي directed towards west. Now moving to another question here. Oops. Sorry. It's because of this. يلا بابا تماشى بسارك. An electron is moving north encounters uniform magnetic field. If the magnetic field points east, what direction is the magnetic force on the electron? يلا بابا بخد تيبل كيبكو كمان بلبزام direction كيتسيا. ماشي electron يشاء قاعد لي قلت مان B V magnetic force on an electron here. Electron يعني negative بابا the back of the hand you can say. Back of hand. But man an electron moving north got and direction motion okay Y positive magnetic field if the field points east. ما magnetic field that point east يعني شبابه يعني X positive. قلنا هم زاري لخوات diagram يبقى this is north, south, east and west باشا. هم زاري west للا يتسبب east إيش لا يواسطة. زور باش كات direction magnetic force okay X معناه Y معناه دي Z بيتن معه. It is either positive or negative. يلا do the right hand rule to see which direction it is. باشا زور باش كات قلت ما magnetic field it is pointing X positive that is X positive. You can see that here. Direction motion it is Y positive. But man because it is electron the back of hand one yeah got that the back of hand is pointing up يعني يعني Z positive and that is what it is. got the Z positive بابا إذا ما دام باسي north باسي east كده got that the 20 blame upwards here. ماشي positive زي يعني upwards يعني out of the page وانا ايش اسايا بسارش دي كش ماني دي بساري دي كمان هي بابا دير انا زوزو راسا انا بسار انا محاولك اخذ حاليا كا اوش دايركشن كان طبعا انا دايركشن كي ليري بكار بين زوزو راسا انا ليري بيس برايت هاند رول هناك اقول لي اراد this بيبكي this one would be actually let me just do this one by the way اسكب بسارك عندك جاهزة بسارك دلت بابا ضلوا in which situation the direction of a magnetic force on a proton moves in a magnetic field is to the left of the page. بخوي بدلي direction كشي بابا direction it is towards the left of the page. ما ليه بيكن there. ماشي ضلي magnetic field, velocity and magnetic force. Let's change this color here. Hopefully we can get. No, actually this is even worse. I think this one is fine here. باشا بابا. One direction magnetic force on a proton باشا. It is to the left of the page. يعني direction magnetic force okay دبي left يعني شباب يعني دبي X negative بيتن. This must be the direction of what? The direction of a magnetic force. أقول لي الرادة سبيكين بابا. There are the 20 بالإنها direction magnetic field okay. Let's start with option D here. Direction magnetic field okay is out of the page means Z positive. Direction velocity okay. It is also X negative. When you got that, this one cannot. We said we cannot have to same direction كواتا it is not option D. برو option E C بابا. Yeah, but man option E C هم دي ثاني you can see that the direction of a motion man force كده B left B يعني x negative B. And this one is also towards x negative كواتا أوش ناكرت. And what about the direction of a magnetic? What about B here? يعني غير B بابا تماشاك قلت man force كده. The question says which one of them is to the left كواتا force كده B x negative B. ليرة magnetic field كمان here it is directed towards x positive when ما ناكرت two direction هبيتن even if they are positive negative kata, even option B is incorrect. Kata, what is the only option that is left now? It is option A, right? So let's take a look at a magnetic field that is into the page Z negative motion it is Y positive kata, force the BX negative beaten, and this is how you can get the answer without even doing the right hand rule then, just by using the table. Masha, this is how easily you could do these questions. This study tip here is something very important. This is why I would like to leave this one for the next session. That'll be the end for this session. Keep practicing those things, especially the right hand rule, so that you can get the hang of it, inshallah. Till next time. I'll see you soon, inshallah. Assalamu alaikum wa rahmatullah.